Okay, so homework for today was Towers of Hanoi thingamajig. You didn't have to play the whole game though, right?
No rules.
Okay. So display the towers, but no rules. You could put a bigger disc on top of it. Okay. So get the mechanics of it working manually, because I said I was going to do input today, right? Does that all sound accurate? All right, let's go do that. All right, and we use Ubuntu in here?
Yes.
All right. You can do it. It doesn't look like it's doing all that well, does it? Unable to complete the operation. Let's see, can we force a restart? Oh, it looks like it's up now. Just took a little coaxing. Okay, so let's start writing some of this stuff. I already created the directory for Towers of Hanoi, and then we introduced a stack, and what I indicated that towers are stacks and our disks are like nodes. Does that sound pretty accurate? Okay, so what we're going to go ahead and do here, I'll just implement it again. I don't want to talk about inheritance in C++ yet, and we'd have to change so much stuff to make it work for disks instead of nodes anyways. So for right now, I'm going to go ahead and I'm going to create a disk .h class. All right, and this guy is going to be a class called disk. And he'll have a public section. Actually, let's do the private section first. And a public section. So for a disk, let's go and kind of design this guy over here. When we think about our disks on our Tower of Hanoi, and actually let me get it open here on so we can visualize the game here. All right, so here's our 3 towers. These are our disks. So when we think about these disks, what differentiates these disks from each other? Their size, right? Visually, we might say color and all this other stuff, but we're not quite at that point right now. So, we're going to say that these guys have different sizes, and we might have to play around with the size of it a little bit to get it to look right. But let's just say that maybe this guy has a size of 2, 4, and 8, something like that. All right. So we're going to go ahead and we're going to say that a disk is going to have a size. Okay, and this guy is we're going to call this guy the value of, and so we're going to say this guy drives the value of the disk as well as how to display it, something like that. Okay. For right now, we can just say that's it for a disk. Now, a disk is going to be part of a stack. So a disk does need to know about the next guy in the stack, the next guy in the tower. And what kind of animal is the next guy in the tower? What kind of variable would be the next node in this case? A disk. So he's going to have a disk pointer, so the size would be probably an int, right? And then we'll have a disk pointer, next disk, something like that. All right, so for our private variables, we're going to have an int size, and we'll have a disk pointer. maybe called next disk, something like that. Okay, and then we can go ahead and I think we can make some pretty quick guesses at what abilities we might need with this guy. We're going to probably need to get the size, and then also get and set next disk. Go ahead. Oh yeah, thank you. It actually would work with .h, but I've been using .hpp.
Does it boil down to the same thing?
Ultimately, it does, but more modernly, if you remember at the beginning of the semester, you probably didn't we write some paper that looked at the history of C++. The more modern version of C++ has adopted HPP files because it's not uncommon anymore to have a mixed batch of like a program that uses both C and C++ in it. So an HPP file, I think it has some other benefits as well, but it also lets you kind of know what belongs to likely a C++ based source versus C. A question to the back? No, not anymore?
Oh, I was under, I guess that's probably the reason why I was having so much issues because I was trying to use stack as my, as the base for.
And you could. So, I mean, we could say that this guy is a stack and enhance it from there. The problem with, I would have to include stack.hpp there. And we're going to talk about inheritance in here. In this case, actually, it wouldn't be stack, it'd be a node for this guy. And tower would be a stack. Where when you take the inheritance model says we are a copy of everything that guy is, and then we differentiate ourselves a little bit. The issue with it is the way we already have our stack and our node written, nodes are very much integer centric and stacks are very much node centric. So we'd have to basically change everything in there to be more of this disk centric and thing. So you might as well just rewrite it rather than somehow attach yourself to something that was a stack and then have to re-implement all the pieces. Yeah. Well, I mean, that would have had another issue associated with it. So, I mean, it's not incorrect to do that. The segmentation errors usually are you're trying to, well, I mean, almost always, you're trying to access a place in memory that doesn't exist. So that would have been more with implementation. There's nothing that says we couldn't inherit from node here and make a disk, create a disk in terms of nodes. We would just have to change what the payload is. And so in this case, our payload is our size and our next node is next disk. So we've changed the entire thing, right? So we might as well just write it from scratch. But I'm going to go ahead and make a pretty good guess at some of the functions we're going to need. We're going to need read-only access to size, and we'll probably want read-write access to next disk, because this guy is potentially going to kind of be moving around our towers, right? All right, so we'll go ahead and we're going to have an int get size. We'll have a disk pointer get next disk, and we'll have a void set next disk to a disk pointer D, something like that. All right, so I'll copy these and we'll go write the disk.c file. All right, and the first thing we're going to do is we're going to include disk.hpp, and we'll implement our various pieces here. So get size will return this size. Oh, it's disk CPP. Hey, hey, hey. My 450 class uses C as their base language. Close disk.
disk class. Like.
Oh, thank you. All right, and then next disk. This guy is going to return this next disk. And then this guy will take in a value and set next disk equal to that guy. All right, so we've implemented those pieces of what a disk is in our, and we might expand on that. We probably will expand on that. We'll probably ask for a disk to maybe return its display string or something like that soon. Go ahead.
This is just a question in general, I guess, with pointers. So I guess I'm just a little bit confused on why it necessarily has to be a pointer up there. Like why you can't just set the next disk to be just a disk key.
You mean this guy?
Yeah.
You can.
Okay.
But this goes back to that whole thing of C++ empowers the programmer to hand you the house
Okay. Mm-hmm.
or to hand you the address of the house.
Sure.
So
Is the only reason why it's complaining just because in the header file it just
there it doesn't match up.
Okay.
Yeah, but I mean, understand that if I'm passing the entire disk,
Yeah.
that's heavy.
Yeah.
You know, if we're thinking about, I mean, it's not that heavy, but relatively speaking, it's a lot heavier than a 32-bit memory address.
Sure.
So yeah, in Java, the decision's made for us. It says it's an address 100% of the time.
Okay.
We would probably say in C++, it should be an address. We'll leave a little wiggle room and say 99.9% of the time. But C++ empowers us to choose as the programmer.
Okay.
Does that make sense?
Yeah.
Okay. Yeah, it's definitely not illegal to do that.
Okay.
It's just maybe unwise and certainly not memory friendly.
Okay.
All right, any other questions on that? That's more of a pointer question. That's pretty important stuff that we're dealing with.
What's the case that you would want to
If you wanted to make a change to an object without it impacting the original value. Because, when you pass something by address and you make a change to it, you're changing it in real memory. Let's say that you were passing something in and you knew you were going to manipulate it a bunch, but you didn't want those changes to be permanent, but you wanted them to be temporary. Then you could maybe pass something.
like testing something?
I guess, but even then, I might still say it might make more sense to pass in the pointer and then create a duplicate object based on that, like create a function. Java has a function called clone that's part of all objects that will literally create a duplicate, new memory with a duplicate of everything inside that new memory, so you can just work with the clone knowing you didn't impact the original. We haven't done that in Java, but it's a built-in function all objects have. So we could write our own similar thing where we just allocate new memory and fill that guy up with all the same stuff as this guy and just return the pointer to it. Okay, so we'll say that's our disk for right now, and then we need to write a tower. HPP, okay, nailed it. I'm allowed to have typos today, by the way. I have 102 fever, so it's just, I'm not contagious though, by the way.
You're saying coronavirus is coming to the U.S. and I don't think trust you.
I don't have the.
Your doctor couldn't even properly diagnose you. How do I know?
That's true. This is all inside. This is all inside stuff, not outside stuff. Yeah, I think corona is more like coughing and pneumonia-y type stuff. I don't have any of that.
No. And usually it says it's only affecting older, younger, and sick, like already sick.
Yeah, people who have compromised immune systems.
Yeah, people who are
they aren't able to fight it off. It's not that the virus is exceptionally you know, more complex or, you know, more dangerous than a lot of flus. It's just, it happens to turn into pneumonia pretty quickly. And
Just have to be smart.
anybody who gets pneumonia, if they're have a weaker immune system, they're in trouble. My wife had pneumonia 3 years ago, and she got it 3 times in a row. You know, you go off the antibiotics, you're better, and then, but it didn't quite get it all, then it comes back, and you keep going back on.
It's annoying.
All right, so our tower, this guy's going to function as a stack, okay, but it's going to be a stack of disks. We can still think about it as push and pop and those things. So this guy is going to have a disk pointer that's going to be the top of our tower. And if you wanted to use a different naming conventions, you could have. But we'll say we have a disk pointer that's the top of the tower. We're also going to have a probably a display function, but we'll get to that here in a little bit. So we're going to want to have a push, pop, and is peak going to be helpful for us? So if we kind of think ahead a little bit when we're deciding whether or not a particular, well, first of all, you want to peek at the top of the tower to see if there's anything on that tower. We can even have maybe a count on the tower too. We didn't do that before, but we might choose to have a count on our tower to have a quick, if there's 3 things in this tower, we're good. If there's 0 things in this tower, it's not a legal pop. Something like that. But, you know, when you think about when we start applying the rules to it, if I have in waiting a disk of size 2 and I'm getting ready, well, a disk of size 4, let's say, and I'm getting ready to push it onto a tower that has a disk of size 2, it might be beneficial for me to peek at the top of that tower I'm about to push it onto to see if that's a legal move or not. Okay? So in any case, let's build these guys initially. We're going to take a couple different approaches to push where we might decide to return a Boolean, whether the push worked. We could build our logic for putting something in onto a tower into push, where we say, okay, I'm going to put this disk, I'm going to try to push this disk onto tower 2. And he's either going to accept it if the rules applied correctly, or he's going to reject it. And he's going to tell me whether it worked or not. All right, and that's going to be either legal input or not legal input. All right, but we'll build a count into this guy for right now. We'll go ahead and build in our peak. So a tower is going to be a class called tower. Looks like this guy. And we decided, so we're going to have a private section and a public section. And the private section, we're going to have a disk pointer called top. We'll have an int called count. We're going to need to import. It's not import, it's pound include. Disk.hpp. All right. Then we're going to have our couple of functions here. So we're going to have a I'm just trying to think if we're going to need, we're probably going to want to get count as well. So let's do an int get count like that, just so we can report on the count, whether we use it or not. That we made it private. We need a way of accessing it. We probably don't want to externally change the count. Count should only change as a result of pushes and pops, right? We shouldn't be able to just externally say, the set count to 7. Paying no attention to whether or not the thing actually has 7 disks in it or not. So we should be able to give ourselves a read-only access to count. And then we're going to have push, which is going to be, at least for right now, void. And this guy will take a disk pointer. We'll have a pop. Now, before when we did our pop and we did our peak, we had to give us the integers, right? The actual values that were in there. We're really kind of thinking about what's coming out of the tower is I actually want the disk. right? I don't care about the size of that thing. I want the actual object because I'm going to take that object and I'm going to put it someplace else. All right, so that kind of drives into our decision making. Similarly, if you wanted to build your tower in terms of our previous stack, you could have chosen to still use nodes, but have the payload be a disk pointer. Does that make sense? All right, so we'll have this guy return a disk pointer. So pop will give us the disk pointer, and peak will do the same thing. At least for now, we might decide that maybe peak gives us the size instead, because that's kind of what we're maybe interested in, but we'll just keep them the same for right now. All right, so we'll go ahead and steal these guys here, and we'll build our tower.cpp. And we'll include tower HPP. Go ahead.
Would we want pop to return an int, or do we want it void?
Well, you definitely don't want it to return. Well, pop takes something off the stack.
Yeah, I just know originally we returned it and,
Yeah.
and removed it.
Right.
We wanted.
Well, it's definitely going to remove it. So like what I was just saying is that if we're going to pop something off a tower, so go back to our picture or go back to the actual thing. When I pop this guy off a tower, he's still maintaining his diskness, you know, because I'm going to push him onto a different tower. So I probably want to get the entire object. Where before we returned an int, which was we had a stack of integers. You could say, well, I could have it return. You were kind of suggesting maybe have it return the size.
Yeah.
We could do that, but then we'd have to build a brand new disk before we which could work, but pretty memory efficient, right?
Yeah.
Okay, if I popped the thing off there and I said, okay, destroyed, I just have the size of that guy. Okay, and then I say, okay, I'm gonna put him onto another thing, so I'll go ahead and create a brand new disk of that size, and we start having some issues.
Okay.
And we didn't write our constructors yet anyways, so yeah.
Okay.
Probably not if we think about what we're trying to mimic here, the idea is when we pop something off one tower and push it onto another tower, it's that same disk object.
Okay.
So that's what we're mimicking. That's the problem we're solving, and our solution likely should mimic that unless we have a good reason for it not to. Okay, we'll get back to the constructors in a bit. I'm sure I'll forget, but it's on you, Clancy. All right, just making all these guys part of the right class. All right, so get count. This guy's just going to return this count. Push. Right now, you're not having to apply any rules, right? So right now, push just puts it onto the stack. All right, puts it onto the tower. So we're going to ask that question. If this top, so if we currently have a top of the stack, I want D to point to the same thing that top points to. So D set next disk to top, and then this top is equal to D. So now that guy has become the new top of the stack. Otherwise, if the stack is currently empty, then I'll just say this top is equal to D. In either case, I'm going to say this count plus plus. Now notice here that this line happens in both of these cases. So I really could say that. If there currently is a top, I need to make sure that D points to the same thing top points to. Regardless, top is going to point to D, and my count will go up. See how this is the same logic? If you like the other one better, that's fine. This just streamlines it a little bit. So the idea here is that this line right here, well, actually both of these lines will occur whether this is true or not. If this is true, we definitely want to make sure we don't lose track of the second thing in our stack. That's what that if is dealing with. All right, so that's what a push does. Pop, well, let's just do peek real quick because peek is easy, right? Peek says, here's what's at the top of the stack. Don't change anything, whatever. So this guy will return this top. All right. And then pop, this guy is going to actually return the top of the tower, but also disconnect it. All right. So I'm going to give myself a disk pointer, maybe called temp. Let's call it disk to return. And this is going to be the top of the tower. All right. Then we need to adjust the top of the tower to point to the next guy in the tower, right? So we'll say this top set next disk. This top is equal to this top get next disk. So we'll set the top to be equal to his own next disk. That's the new top of the stack. We'll say this count minus minus. Reduce the number of things on the stack. I like to purposely clean up things, so I'll say disk to return set next disk equal to 0. I like to actually disconnect it, even though we know we're going to be overwriting it in a moment. So we're going to call this line optional. I just like to clean up the mess. And when I remove something from a data structure, I like to fully remove it from that data structure. Go ahead.
For using 0 and using null, are they almost the same thing?
They are the same thing. They are the same thing in C and C++.
Okay.
That's why, because, there's kind of two different things here. 0 and null mean the same thing for pointers.
Okay.
0 and 1, 0 and not 0 is how Booleans are handled. That's what allows us to ask questions like this.
Oh, okay.
If this top.
Oh.
If that guy exists, that is saying if this guy is something other than 0. That's what that's asking.
Gotcha.
So really what that is saying is it's not equal to 0. That's equivalent to what it's saying.
Okay.
Is that only a C and C++ thing?
Yes.
I tried it in Python and I got some errors.
Yeah, I mean, don't treat it as like it's a special case. This is a Boolean expression, right? Ifs always require Boolean expressions, and in this case, the Boolean expression I'm asking is whether or not this is the same thing as, this is saying if this is true, is true not equal to false? That's a true statement.
Yeah.
Right? So I might as well just use the true value itself. We are able to do this in C and C++ because Booleans are just specifically implemented as integers. In more modern languages, I can tell you that under the hood they are implemented as integers, but they are protected wrapped by actual Boolean types. So we can't get to the int thing. Technically, you could do math with a Boolean value in C and C++. I don't know that you'd want to, but you could, because it is a 0 or a non-zero number. It's a number. Just like chars in all of our modern languages are actually numbers, right? You know, it's the same thing here. If you were in the 450 class where we're writing an operating system, because we need to deal with a lot of bite-sized things being passed around representing memory, we actually have to represent everything as char pointers. That's the only way for us to get to an integer size of size 8 bits in that language. So you're like, well, why am I holding numbers in char pointers? That's because just because it's called a char, it's an 8-bit int. That's what chars are.
Yeah.
So it's in Java they're 16-bit because of Unicode, but in C, chars are 8 bits for ASCII. Yeah, so I mean, it's not that C and C++ are some kind of special case compared to modern languages. It's just that
There's less protection.
Booleans specifically are numeric. That's what they are, so we're able to take advantage of that. We can maybe make the argument of which is better. I would say the more modern approach is better, having specific trues and falses, even though they might be implemented numerically under the hood. I think a Boolean should look like a Boolean, from a programming perspective. Go ahead.
I was trying to use Booleans kind of throughout this to solve something, and I had it where I was nesting two ifs, and sometimes for something, the first one was true for whatever was going in, but maybe the second one wasn't, and it wasn't going to else, and I felt like it was getting stuck. Like, how does that work if the first one is true?
Well, I guess I'd have to see your if structure, but it's no different than Java. But let's just say I had an else in here, but then you had a second if inside here is what you're saying? If you get into this if, you will never hit this else. It's a completely separate dude, right? Because ifs are always it's this one or it's this one, not both. So if you entered into this guy right here, then you ask this one. Otherwise, you can throw an and up there and,
I was trying to
yeah. But the short answer to your question is it's not any different than Java or Python for that matter. The structure for ifs are the same. Okay, so let's see, pop. Pop, we're going to go ahead and grab the disk that we're going to want to ultimately return, which is the current top. Then we'll go ahead and update top to point to the next guy on the stack. We will decrement our count, and then I like to fully disconnect nodes as I remove them from data structures. This sets the disk to return's next node to nothing. He is a free-floating entity now. Choose your poison. You'll probably find lots of books that don't do this. I think this is good programming maintenance, but you've heard me say many times, don't do something just to save a line of code. Go ahead.
Do we have to use parentheses there instead of the equal sign?
Yeah, definitely. Where were you on that one, Clancy?
I told my head. I slacked.
Yeah, set next disk is a function, so I need to. All right. But then ultimately I need to return that disk, right? So return disk to return. That's the disk pointer that I'm returning. Now, technically, I'm only going to do any of this stuff if I have a, so if this count is greater than 0, do all this stuff. Otherwise, I can return a 0 for null. What's another way of me saying count greater than 0 here? What's a synonym? A booleanym? Yeah, give me a non-numeric verb. Well, I guess it technically would still be numeric. What's an alternative to using count here? Because really I'm asking, is the list empty? Okay. Mm-hmm. So if this top. So if the top exists, then I can go ahead and disconnect it. Otherwise, you're trying to pop something off the empty stack, return 0. Return null. So you can choose which of those you prefer. They're asking the identical question in 2 different ways. Okay. So questions on that? All right, so we need to go ahead and create our constructors now. I forgot to do that the first time through. So we'll have a public constructor here. This guy will be a disk, and a disk will take in a size. And we'll go ahead and implement that in here. And we'll say this size is equal to size. And in the same vein, I like to specify that the next disk points nowhere, even though I can pretty much promise you it already started off with a null value there. This kind of falls into the category of all programming languages have default values for things. So for instance, if you define an int a, typically a will be equal to 0 by default. Modern languages will give you errors saying that this value may not have been initialized. Older languages like this, unless the compiler has been updated to give you warnings, you can give it different flags to turn them off. It'll say, hey, you can start doing math with that default value, but it's not good programming practice to trust default values. Because at any point in time in the future, a new compiler or something like that might treat that default value as something different. Maybe default integer values become -1s instead of 0, something like that. So if I want the next disk to be null, set it to null. Now I don't care what kind of language I'm in, how much in the future, whatever. The value of that guy starts off as null. I fully control the situation. All right, questions on that?
The disk.hpp.
Nope.
Okay.
All I added was this. And the constructors do not have a return type. Okay, you good?
Wait, on disk. In size. Okay. Will be total.
There's an available update.
I got this.
You good now?
Yeah.
All right. So I'm going to go into tower, and we'll go ahead and create our constructor for tower. A tower doesn't need anything to initially work. It's just going to be an empty tower. Let's see, where's tower CPP? All right, but an empty tower will set this top equal to null, and it'll set this count equal to 0. Both of which I can almost guarantee you were the default values for those, but in this case we are explicitly setting them. All right, that makes sense? All right, so let's go ahead and let's allow a tower to display itself now. All right, here, just real quick, let's just go into our driver CPP. We'll dump our stack stuff. Let's just make sure we don't have any stupid bugs inside of our towers or anything. So I'll go ahead and say tower pointer T is equal to new tower. And I need to make sure I include tower HPP. I'm also going to need to include disk HPP because I'm going to be directly making disks inside of here as well. Then we'll go ahead and say T push new disk 2, something like that. New disk 4, new disk 8, and then we'll go ahead and do standard cout t get count. And that should give me a 3 things on that tower. Here, I'll remind you here this. So if I do a history and I say grep for all these things, this is a, I want to compile all my C++ files. Notice I've done that a whole bunch of times. I've typed it a bunch of different times. So here, we'll just remember 630 is our good one, for example. So I could just say bang 630, so exclamation point 630, and it will do that, that code. So let's see, what is this guy not happy about? Does it not like me? Shouldn't have to put those inside of a variable, but it might want me to put parentheses around it. So this is my constructor. Oh, give me a moment. Oh, it takes in size. What have I done? That's right, that's right, that's right. Set next disk returns void. That looks fine. Takes a disk pointer. Takes a disk pointer. Anybody see something obvious? Has no member called set next disk. This is color coded funny. And I do call it next disk, right? Yeah. Yeah, that's how I write the constructors. I just flip back to it and it's like it's cool now. All right, what do we have in here for our Isn't that weird? I didn't change anything. Redefinition of class disk, tower, and driver. Oh. Okay. Remember that whole if not defined stuff? So in this case, our tower, let's see. Well, actually, in tower, I don't include. See, that guy should have been a problem. So that in here, in my driver, do I not need disk HPP? I only have one file called disk, right? Disk CPP, disk HPP. Okay. I just want to do something here real quick.
This happened to me and I just included it one less space because I think I may have included it too many times. That worked.
Well, I only have it included once, unless I typed it twice. All right, so disk. Oh no, that's. So disk needs to know about HPP. Tower. Oh, hold on. That's the problem. Oh no, that was the problem. So I had in tower HPP as well as tower CPP, I included disk both times. By doing it inside of HPP, I actually already had access to it because I needed it for this disk star. So that's what it was complaining about, is I had it more than once. Now when I get to, so since tower HPP has that, I should be able to get away without having it inside of driver. I just need to have access to tower. But I was using new disks in there, so I actually think I'm going to need it. But at the very least, that should compile now. So if I run this, this is going to give me a 0. It's my output. If I go in here and I push the disks, this guy should give me an error right now. Oh, so it does flow through from tower. So there's my 3. And that's because tower already includes disk HPP. So that flowed to tower CPP, which then flowed to driver CPP. So since I included tower, I've got disk with that. Go ahead.
Why did it care that you had it twice though? Because wouldn't it just...
Because I defined understand what include does. Include says I'm going to bring the contents of that file into this file. So this whole this header file thing is just for our purpose of having these things separated into different like little modules. So if I include disk.hpp twice, I'll have the class called disk and then the class called disk
Okay.
before these.
Okay.
And it's saying the second guy this is a class you've already defined, even though it's, both of them came from the same header file.
And they were both the same.
Yeah, ultimately what's happening here is so there's a thing called the linker that happens during compilation where it brings all the different parts of your source code file into like one giant source code file. And kind of creates that. Now, what's actually interesting here, you heard me mention a few minutes ago about that if not defined thing. That would have saved me here from the error, but I would have still had, it would have given me too large of an executable, or an extra large executable. Actually, it wouldn't have. It would have allowed me to include it twice, but the second time it would have ignored because the class was already defined.
Okay.
That makes sense?
Yeah.
So that if not defined thing kind of protects you from yourself, but I think it also then allows you to write code that isn't, I don't even know about efficient. It's one extra step by the linker, so it's inefficient but only a compile time. I'd maybe just say incorrect. It'll let you get away with something you shouldn't have been able to otherwise get away with. All right, so there's my tower with some disks on it. Looks like I didn't have to put these parentheses. I was originally thinking it was something weird with the using the new keyword directly for my towers. Yeah, it didn't hurt anything. I just was thinking that was what it was complaining about. I can't necessarily tell you what the original issue was. It'd be more in Clancy's world. Like my gut feeling is I had forgotten to save a file again. That's all I can think about while it was giving me that error. Like I had not saved one of my files, so.
Jump on Clancy the second.
Well, it feels like that's a pattern I'm going to have, so we need to really pay attention to saving files here, Clancy.
Yeah, it's all my fault. It's always my fault.
All right. So now I have my tower. We probably want to go ahead and have the ability for a tower to display itself. And we're not going to, like I told you, don't spend time making this look pretty. So I'm going to have this thing left justified, whatever, blah, blah, blah. So we'll go into tower HPP, and we'll go ahead and have a void display. And oh, see, I was literally just about to do it. I was about to forget to hit save. Man, Clancy, you're killing me. All right, so this is going to be a tower method. And so for this guy, I'm going to go through and display the contents of my stack to the screen, and you can decide to put like a little underscore thing at the very bottom or something. So maybe I go ahead and I say disk pointer cur disk is equal to this top, for int I is equal to 0, I is less than this count, I plus plus. We'll go ahead and print out the, what I want to do is I want to get the size of a disk. So I'm going to actually ask each disk to display itself. So I'm going to pause this for a second. We'll go into disk HP, and we'll teach a disk to display itself. And what does display mean for a disk? This is actually going to be an interesting one because I can do this with either string. Go ahead.
This would be the disk colon one.
Yeah, it will.
Okay.
You see, you can see he's on top of things. I literally had just pasted it and the arm was already up.
IRM is
It's just, I mean, to the point where I was going to write it, but he didn't even let me miss a beat. Not a beat. All right, so, and here's the thing is, let's say that I have a size of 2. Maybe I want to represent that with equal signs, something like that, 2 equal signs, where a disk with a size 4 has 4 equal signs, 8 equal signs, something like that. That's how I'm going to visually represent my disk, something like that. The issue is as I could cheat, let's say, and I could say for my display, if, and keep in mind, this is really operating off of pre-knowledge of what size might be. So I could say, well, if this dot size is equal to 2, then I can go ahead and do a cout 2 of those \n, something like that. This is standard. That makes sense? Have to do what? Oh, IO stream, yeah, thank you. All right, so I could say if it's 2, give me 2 equal signs. If it's 4, give me 4 equal signs. If it's 8, give me 8 equal signs. Well, Towers of Hanoi can start supporting lots of different size disks. I probably don't want to have this hard-coded count. So I want to build a string with this number of equal signs in it. That makes sense? Now, in order to do that, let's see, am I going to need standard lib? So for your assignment, you could have done this equal sign thing. I think this is in, actually, let me leave it out for right now, and then I'll go and get it. I think it's in standard lib. So I want to create a char pointer. Let's just call this guy C. And he needs to be big enough to hold all of my equal signs, let's say. A couple different ways I could do this. Well, first of all, maybe the most straightforward way is since cout doesn't require me to do \ns. Where are we on time? Yeah, actually, let me remind me to talk about string concatenation-y stuff later. I'm just going to do it this way for right now. For int I is equal to 0, I is less than this count. Actually, it's this size. I plus plus. I'll do standard cout. An equal sign like that. And then at the end, I'll do standard cout. \n. So that'll be the correct number of equal signs. What I was going to do is I was going to allocate enough memory for a string, then fill it up with equal signs, and then display a single string. So we'll talk about strings more later. So this will just display the right number of equal signs for a disk. So then when a tower displays, I'll grab the current disk. I'll ask that disk. I'll say cur disk, display yourself. And then I'll set cur disk equal to cur disk get next disk. And then if I really wanted to, I can, put a little maybe line underneath it. We'll just call that good enough. And import IO stream. And I'll give myself my \n there to kick it down a line. Okay, and then back here in driver, I'll go ahead and ask my first tower to display himself. I have 3 towers and Towers of Hanoi, so I'll push the discs onto the first tower. I'm actually going to push them in the other order, right? The biggest one will be on the bottom. All right, I'll say T1 display, T2 display, T3 display. So there's my first tower, has all 3 discs on it. Second tower has no discs. Third tower has no discs. And then we'll do a manual move of T2 push, T1 pop. And then we'll have the, and actually let's do a T3 push, T1 pop. Then we'll display it again. So this should have 1 disc per per tower. Probably want to label the towers. 1, 2, 3. So this is 1, 2, 3. So it's correct. It just looks ugly. All right. So I think that was homework. Build the structure for the game. Allow you to manually move stuff between. That makes sense. All right. So now I want to teach you how to do I/O. So let's say that we're going to be reading in a value. All right. So with I/O stream, we've been using cout, even though I don't need I/O stream in what I have in here right now, but we're gonna need it for a second. There's another thing called cin. All right. So what I can do is I can say int a, right here. Let's do this. Standard, cout, enter a number. And then we're going to say int num, standard cin, num, and then we'll say standard, 1 second. Cout, the number you entered is num. Enter a number. There's my 5. The number you entered is 5. Go ahead.
This is basically the next input function from
Scanner.
Java.
Yeah.
Scanner.
It's like our scanner in Java. Now, if you looked at some other, so cout is kind of, cin is the way of doing it in C++. If you were to do this in C used something called Scanf. There was also an Sscanf for specifically reading in a string, which is a series of characters. But cin, so for instance, if I do something like this, char pointer, I think cin handles this, char pointer C, and then I say standard cin C standard C out. The string is star C. \n, something like that. So there's my number now, which I didn't prompt myself, but now it's waiting for me to type in a string. Yeah, so I would need to give myself memory to fill it up with. But we don't need to read in strings. So let me show you how to read in strings next time. We need to talk about strings anyways, but this should give you enough to do your assignment, because what we want to do now is, now that we have the ability to read in from the user, we want to say, you know, ask the user for the source tower. So if we'll just dump this for right now, just so you have the example that you really need. So here, I'll go back out here. So maybe your thing looks like this initially, or you could make yours look prettier, whatever. And so maybe this is tower 0, this is tower 1, this is tower 2. So you put kind of names of the towers above it. In fact, if we really wanted to, we can come in here to tower. And I can call this guy, maybe it's tower number. I'm not going to do it as a string right now. And then maybe tower takes in a tower number int. So here's my constructor for this guy. And I'll say this tower number is equal to the tower number. And that way I can incorporate it into my display. So down here at my display, I can do something like standard C out tower number. Did I forget to save again? Oh, inside of my driver, I need to give it the names of my towers. So this will be tower, I don't know, 1, 2, 3.
Wait, you have to save it?
I did. So there's my tower 1, tower 2, tower 3. So the idea would be, for your homework, you would say, what source tower do you want? So maybe I'd put in a 1. So it would pop off of 1, and then it would push on to 2. For instance, what's your destination tower? So source tower 1, what's your destination tower 2? It'll pop off of 1, push on to 2. Source, destination. Make sense? But get the logic for towers of Hanoi working, where you can only put something on top of a on top of something that is larger than it, and then also detect a winner. And a winner is when tower 3 has a count of 3, right? So actually pretty easy to detect a winner. Question? Yep.
You want us to make this continuous, so it just keeps going?
Oh yeah, keep going until there's a winner. Yeah, keep going until there's a winner for the game. You could always maybe give yourself a little extra spacing here for sanity's sake, but whatever. All right, and then I'll go ahead and I will push this to GitHub. All right, so GitHub has the updated code from today. I'll put the assignment up, and I'll see everybody on. What day is today? Thursday. I'll see everybody on Tuesday.